welcome to Science Never Stops. I'm your host Joseph Vick with the U.S. Space and Rocket Center, and today's topic is geometry, getting into angles. Geometry is the branch of mathematics where you study shapes and angles and their relations to one another, and angles happen to be all around us, and angles even make up some of the most basic shapes, which the video prior to this one, we went over the basic shapes, and we're going to review that once we discover what angles and the kinds of angles and the naming of those angles and how they apply to those shapes. First thing is the parts of an angle. There are two main parts of an angle when you look at it. The vertex, so as review from our shapes, vertex means a corner. So the very corner point of that angle is our vertex. And sprouting out from that vertex, you have two arms. Just like on our bodies, we have our main core, our chest, and our two arms. So we can make our own body angles with our chest vertex and our arms for the outstretched angle. And the angle in the center is actually a measurement. It's a measurement of the amount of turn with the arms. So how wide those arms are from one another. Now when we're doing measurement of angles, we use a special tool, and that special tool is called a protractor, where it uses measurements between 0 and 180. So these are measured in degrees, not like brr, it's cold outside degrees. That's temperature. These are degrees of arc. So you see the arc or the curvature of this protractor. Arc in the form of, if I do one on top and continue around, it makes a full circle. So that arc rotation, just like on a clock. When you see the arms of a clock moving about from 0 to 180, and then you keep going, you reach a full 360 degrees, or a full rotation. So that's why they call it degrees, because it's degree of arc rotation around. So for these angles that we're going to be measuring, we're just going to be using our basic half protractor with 0 to 180 degrees. If you happen to have one of these around your house, please pull it out for this activity. You can use it when we're measuring and creating our angles, and you can use pencils or straws to help determine what angles we can find and measure with the ones we're about to review. So let's get started with our 4 different types of angles. Now, the most basic type of angle is what we call a straight angle at 180 degrees. And notice it looks like a straight line right across the page, which basically that is what it is. It is a straight line measurement of 180 degrees. So if we're going to use our protractor, we're going to set that up and line. There is a small little, yours may have a hole, mine's got a little line right there. Line that up at the vertex, and you'll notice it reads across the bottom that one of the arms is at 180. So 180 degrees for your straight angle. If we're going to do that with our straws, we would have one arm of the straw on one end of that. Here, let me hold it so it's a little bit, there we go. On one end, and the other arm on the other, the vertex in the center, and that would be your straight angle right there, 180 degrees. The next is what you call an acute angle, and in mathematical verbiage here, I have an acute angle is greater than 0 degrees, but less than 90 degrees. So you still have the vertex and the two arms, and a good way to remember an acute angle when you're looking for one around you is that the letter A itself is an acute angle. So if I turn this angle and I were to put a line right there, that's the letter A. So that's how you would note. So think of it as an acute, a little tiny angle, greater than 0 but smaller than 90. But how would that look on our protractor? So let's put our first arm down to make our vertex there. And with an acute angle, we have anything that is within this range of motion here. Anywhere in this range of motion here. Straight up and down would be 90, which is going to be our next angle that we're going to be looking at. But anything less than 90, but greater than 0, is what we call an acute angle. Now, my favorite angle is the right angle. So the right angle is very important for carpenters or doing any kind of architectural work because of that clean line that forms that square angle at the vertex with your arms to each side. Now, a right angle is what we denote as 90 degrees, and it is what we see when we look at the shapes of squares and rectangles. And right angles are straight up and straight out, just like this. Sharp corners in your rooms, buildings, all have those sharp, clean 90-degree angles. The next angle, the big angles, wide angles, are obtuse. That's a fun word to say. The obtuse angle, and in mathematical speak, it is greater than 90 degrees, so it's larger than a right angle, larger than an acute angle, but it's less than 180 degrees, so it doesn't go all the way down, all the way over to the back end of the protractor like a straight angle would. Notice you still have the vertex there in the center, the arms extending out, and how would that look on our protractor? Line up your arms, start out at 0, leaning up. We have our acute angle range, we hit our 90-degree right angle range, and anything greater than 90 degrees, all the way down, but not before you reach 180. So within this range of 90 and before you hit 180 is our obtuse angle range. And I drew a handy-dandy reference so that we can see all of them together. So a straight angle you have right at 180 degrees, and anything greater than 0 but not quite to 90, we have our acute angle. Right at 90 degrees, we have our right angle. Anything greater than 90 degrees, but not quite to 180 for the straight angle, we have our obtuse angle, and then full out and back down to our straight angle. Now, the challenge is for you to go around, find in your home, find outside in your backyard, what kind of angles can you find, what kind of angles can you name, what can you draw out in your journal to be around you. Angles are important parts of our lives just like shapes are, and it's the sides and the angles that make the shapes. So let's do a review of the shapes that we did for Geometry Getting Into Shapes video. And I added an angle section to each one of the shapes. Now our first basic shape was a circle, and with the circle, remember we had 0 sides, 0 vertices, and also the same applies, we have 0 angles in a circle. Our square with those sharp, clean corners, so we have 4 sides, 4 vertices, and 4 right angles to form a square. Our rectangle, like a square, has 4 sides, 4 vertices, and then we have 4 right angles to form our rectangle. Now, even in the name, you find angles in this shape. Triangle, meaning 3 angles, 1, 2, and 3. The unique thing about the triangle, it has its 3 sides, its 3 vertices, and 3 angles. But it can have different types of angles. It can have all 3 of those types of angles. Acute, right? I have 1 notated by the right angles. If you have a right triangle, you can only have 1 right side. And then you have obtuse. So you can have acute, right, and obtuse triangles for your triangle shape. The oval, like the circle, or the ellipse, 0 sides, 0 vertices, and 0 angles. And the diamond, or rhombus, like the square and the rectangle, has 4 sides, 4 vertices, and 4 angles. Now, I did not denote 4 right angles because on a diamond or a rhombus, you can have an extended length side, making it where those angles aren't necessarily 90 degrees. So that is the review of angles and the review of shapes. I recommend you go about and explore, be your own geometrist, be your own angologist, and find the angles and find the shapes and sides that you can see and find in your home and in your backyard. Write them in your journal, describe them, draw them, and always remember, math and science never stops.